Hi everyone, and in this video I'm going to talk about the new version of my basic OverRig script. It's the version number 7. Let's take a look at the new functions, new features that are present in this new version of the script. The first one is the Change Rotation Order tab. Effectively, it allows you to change the rotation order of your control objects. Let's say if we have this control, let's say we have some kind of animation with this control. The current rotate order is XYZ. Maybe if you need to change this rotation order into something else, you can, you want to avoid some kind of gimbal lock or something, you can click, let's say, this button, XZY, and the animation is going to be recalculated based on this rotation order, on the new rotation order. If you have some kind of breakdowns in your animation, I mean breakdown pauses or something like that, these breakdowns are saved, so they are maintained without any distortions. You can see that I changed the rotation order again and everything works properly. But remember that let's say if you're applying this to your rig, and of course you can apply it to nodes, to any other function, any other locator, but if you're applying some kind of radio animations to your rig, maybe mock-up animations and such, maybe you're using a kind of library of animations, if these animations were made with a specific rotation order and you are changing rotation order on your rig, it may lead to distortions once you apply this new animation to your rig, or once you retarget your animation to this new rig. That's why just don't forget to get the rotation order back once you finished working with it, fixed maybe gimbal lock problems and such. Also, I'd like to point out that in my version 2024, I believe there is a very similar script, very simple functionality of changing the rotation order, but I'd like to say that this script, my script I mean, works like 6 times faster than the standard my version. Again, it's in my 2024. I just use a different algorithm for my script and it works faster and more efficient. Okay, another new feature, it's called Simple Physics. We have a point button for that. So how does it work? You see, sometimes you want to create some kind of physical motion, I mean physics-based animation essentially, from some kind of simple objects. Maybe, you know, bouncing chest, bouncing woman's chest, or maybe, you know, bouncing back on the character's back or something like that, or maybe some kind of object that is wobbling around or just bouncing back and forth or something like that. Something that you want to create essentially based on physics, and you need some kind of simple system to do it without a necessity to simulate physics, to bake the animation from the physics simulation. You see, right here I have 3 cubes. They have very simple animation of moving up. It's very simple animation. I'm going to select those objects, then I'm going to press the point button. You see, those objects were recalculated based on joints, and now they have additional attributes. Radius, of course, is standard one, but they also have some new attributes. And those objects were calculated with, you see, parent constraints. The animation itself is maintained, but it actually was updated based on the kind of physics, sort of physics simulation. The main idea is that we're using this joint. The object is attached to this joint, and this joint has very specific attributes that control the sort of physical properties of this object. You see, inside we have an additional so-called jiggle bone. It is a very small joint, and the object, cube in this case, is attached to this very small joint through the parent constraint. Why does it work this way? Why do we have 2 joints and stuff like that? You see, this approach is far more convenient for game animators, because as you can see, this structure isn't inserted inside your rig or something like that, or inside your object, or otherwise it may break something. It is just a kind of self-sufficient system, self-sufficient rig that exists outside your main rig, but that you can use for your purposes. Alright, so I baked this animation. At first you can see that there's going to be a small lag, but now we have this animation. You can see that our animation was updated, and now it has this physical behavior. It jiggles, essentially. Alright, now I have these attributes, these settings. Radius, of course, it's naturally the radius of this joint. It's a very visual thing just for your convenience. Stiffness, next one. It's the stiffness of this kind of spring, metaphorical spring, that exists inside the system. And the range of this attribute, and it's very important, goes from 0 to 1000. Why such a huge range? Because you have to be very careful with the settings, with the value that you use in this setting. Usually, in order to get the correct behavior, you need some values that are closer to 0, so like from 0 to maybe 20, 25, and everything after that is more, I'd say, precise, it's more nuanced, but more physical, more correctly physical behavior you get from the values closer to 0. As an example, let's set it to 500. And over here I'm going to set it to 1000. Let's take a look. And you can see that the higher the stiffness value, well, it's actually kind of obvious, the stiffer the object, the less of this jiggling effect you're going to see. Right now you can see that these joints, these large joints, are moving in the same way as the objects. The next attribute or the next setting is damping. Let's actually set the stiffness to the default value of 20. The damping setting is a bit difficult to explain, but essentially the damping controls how much of a physics or physical, so to speak, force affects your final animation, your final movement that is baked into your animation. The lower the value, then the stronger the effect of the physics simulation on the animation. The range of this setting of this attribute is from 0 to 100. You can see when I set the value of damping to 10, it gives us very soft physical effect on the cube, on the right cube. The next one is the weight of this physics simulation. If the weight is set to 100, then physics affects the animation fully, or like by 100%. If the weight is set to 0, then the physics doesn't work. So we just see the simple animation that we have on this object. So essentially, through this attribute, you can control the degree of the physics simulation, of how it affects, in what degree it affects the animation. Enable essentially means enabling or disabling your animation, physics simulation affecting the animation. 1 is this effect is turned on, 0, this effect is turned off. Also, as you can see, you can animate this value pretty easily. Also, let's set the weight to 80, as it was previously. Alright. And the last attribute is force. So, essentially, how much force affects the animation, so how much force you get from the physics, from the physics simulation. It's a bit difficult to explain, but I think it's a bit self-explanatory, and it should be pretty intuitive. Alright, what else do we have? Let's say, if we want to have a very smooth effect of our physics, for example, we can set stiffness and damping to 0 and weight to 100. As a result, you're going to see that essentially our physics is going to affect our object in a very slow manner. So it's going to kind of infinitely slowly affect our object, and as a result, our object is not moving anymore. The right one, of course. Of course, if I control the weight, if I change the weight slightly, maybe to 90 or 80, let's set it to 90 actually. Let's take a look. You see we have very smooth, very slow motion. You see how it settles in very slowly. So you can play with these values in order to control how smooth your animation is. Essentially, it's all very intuitive and individual, depending on your tasks, depending on your animation, your character. If you have different proportions, different heights, different weight of your object or your character that you're animating with this physics simulation. Again, all the settings are going to be different, so you have to play with it and find the right values for your goals. But the process itself is very straightforward. You're just applying this effect to a necessary control, a necessary object that you want to animate with physics, and just animating and then baking if necessary. Alright, let's continue. What else do we have? How can we work with this physical simulation? Right now I'm showing you the example with the cubes, but I'm going to show you with the character next. The first kind of idea, the first desire maybe is to bake this animation down, bake this physical simulation down to animation. I baked it. As you can see, we have this result as expected. Now I can select this group and this jiggle plane. You can just delete it. It's not needed anymore because we baked our animation. But maybe you have kind of different situation. Maybe you may not want to delete this physical simulation. Maybe you decided that it kind of looks fine, but maybe you want to play with it later, maybe adjust it. But of course, when you are playing your animation over and over and over, you are forced to recalculate your physics, your simulation again and again. And when you're working with the complex rigs and large scenes, of course, it's not really convenient to work with. And of course, you don't want to simulate your physics from the start each time you're replaying your animation. So in order to avoid this situation, we're going to select this jiggle bone to connect, joint. Then I'm going to apply the knot. And all our physics is going to be recalculated and transferred essentially to the separate locator, separate knot, as it's called in my basic OverRig script. It's over here, as you can see. So it works, but it is kind of baked down to this locator, to this separate locator. So essentially this physics is no longer working, but it gives us a necessary result that we baked down previously, that we kind of simulated previously. And since this physical simulation is baked to a separate object, you can do the following. For example, maybe you like this animation, but maybe you want to tweak it manually. You want to maybe make some adjustments or something like that. You can select this node, this locator, and then using the animation layer you can change this animation. You can tweak it as you wish. Maybe something like this. Let's actually do it again. Let's apply a knot. Also, what is also quite interesting, as I said previously, this joint is repeating the motion of your cube, of your object in this case. But the second joint, again, repeats the motion, but with the physics applied. And let's say, if you select this knot, this joint, then parent inside, use the parent inside function, what we'll get? That's the curve from the physics, based on physics, baked into the animation. And of course you can do anything with this curve that you can do with any curve. Maybe you can make it stronger, so you can amplify the effect, strengthen the effect, and we'll get the same physical motion, but it's going to be far stronger. It's like maybe 3 times stronger in this case, or something like that. Or maybe if you use another of my scripts, which is used for the animation layers, where you can control the weight of the animation layer more precisely. Maybe you can maybe relative to the 0 position, you can extract the animation to the separate layer, to the additive layer. You can use the same motion, the same physical animation, but in an additive mode, thus enhancing this animation. And then we can control the weight of this animation layer. Maybe you can do something like this. Maybe you can make it negative, so kind of invert the motion. Maybe you can make it half, like 0.5. So you have a lot of iterative possibilities, iterative opportunities to control your animation and tweak it as you need. As far as I know, it's very rare technique that because all the scripts that I used for physical kind of simulations, baking into animations, they're kind of simple, and they are not allowing, they're not offering this kind of flexibility. Alright, so we have this physical animation. If I start moving this joint, you can see that the physics was removed because it stopped calculating. You see, it works this way because, of course, it actually goes a bit beyond the basic OverRig script, but doesn't matter. Essentially, it allows you to insert this some kind of these joints, these additional joints into any rig, if you want to make it so that the character has some kind of physics simulations, animations based on this. For example, when you have a character, maybe a female character with large breasts, and you want to make those breasts jiggle, and you don't want to animate it at each and every step, you can use physics for that. And it is very convenient and easy for use with other rigs, other animations. It doesn't break anything. Other scripts that work in a similar way, they're kind of set up in a way that they cannot be integrated into existing rig, and they start moving really weirdly, like in circles or something like that. So there are distortions that happen. And of course, it's not really convenient to use. Of course, if you worked with physics previously, you know that that for the correct simulation you have to use playback speed, either play every frame free or play every frame max real time. And if you don't know the differences, it is time to know the difference. So real time means that my tries to play animation with real FPS, frames per second, maybe 30 FPS, and Maya starts skipping those frames that it can't calculate, maybe if the rig is very complex and it's very difficult to process. In this case, Maya tries to play back your animation with a real-time speed. But if you set it to play every frame, either of these, then Maya will be forced to calculate every single frame. And it is important for simulating physics specifically. And it doesn't matter which one, the second one just has this limit on max real time. So if you set it like 30 FPS, it cannot go beyond 30 FPS. And I also have those two buttons. The first one is essentially play every frame setting, and the second one, or the first one, if we're talking in order, just play real time. And another advantage of this physical system, especially comparing to other scripts that are based on particle systems, such as Z parent dynamic or LM Spring script. This script doesn't slow down your scene when you are working in the same scene with some kind of rig or complex rig, because for some reason when I was working with those scripts with any rig, the scene in Maya was slowing down tremendously. Alright, let's take a look at a more specific example. Let's say I have this animation of this female walk, and there are several places that I want to animate through physics. Let's start with something rather simple. We can animate her butt. This one. Yep. Maybe, to make it a bit more jiggly, a bit more attractive, and something like that. Alright. To be honest, it's not really easy task to do in just straightforward animation approach, because it's very important to actually save the looping part of the animation in order for this jiggle to be looped. Let's try actually doing it. Alright, if we want to make it looped, we can use the following trick. I'm going to select all the controls in my rig. Then I'm going to press the C button, it's cycle infinite. By the way, it's actually very important to check that you don't have any unnecessary frames on the left and the right sides from your animation, because it may lead to your loop breaking, so it may not be kind of perfectly cycled, so it's important to check, just in case. Then I'm going to create some additional frames at the beginning of my animation. Usually I take just the duration of my animation and subtract the same amount. So I have like 32 frames in my animation, subtracting 32, and I get the necessary amount at the beginning of the animation in order for the physics to be simulated properly. So essentially just to warm up the simulation. Then I'm going to select the objects that are controlling the butt, in this case those two joints, and then pressing the point physics button. You see there was a lag at first, but then it kind of settled, and you see it jiggles. Looks kind of odd. Let's control the stiffness. Let's change the stiffness, maybe, or let's maybe increase the damping effect. Yeah, maybe something like this. Yeah, looks nice. All right. Maybe let's make it even more, increase the value even more. Okay. Yeah, maybe something like this. And you see the loop for now it is broken, and it kind of jumps at the beginning of the animation. Another advantage of using this basic OverRig script is that we are not forced to work only with physics, so we're not forced on making it kind of perfect. We can actually tweak it manually to suit our needs. And this manual control actually allows us to exaggerate the animation, or maybe soften this animation, this physics simulation, and so on and so forth. So we have a lot of abilities, sorry. Alright, so we have this animation. Maybe I want to leave this physics as is, maybe I don't want to do anything with it. Maybe I want to change it later, depending on my tasks, depending on the animation. Let me select those two objects. And then on the first frame I'm gonna create a knot. And then I can use the same method that I've shown you previously. I can select the locator, then select the large joint, then I'm going to use the parent and side function. Then again parent and side, alright. Let me change the color actually, just for more convenience. Yeah, something like this, alright. And now we have these curves that we can work with. And it is just a physical animation that we can work with, that we can tweak. And maybe we can use animation layers or anything, or just control the curves. So let's cycle. I'm going to select all of this, I'm going to delete it. And now you can manually cycle it. Let's actually, do it in a different way. Let's create a new animation layer. And then I'm gonna press this button, and this button gonna give us the difference between the first frame and the last frame. You can see it represented in the curve. As a result, we'll have our animation cycled. If I actually turn the layer off, you'll see the difference. You see it shifts slightly because there is difference in the first and the last frame, but with this layer active, our difference is fixed and we can work with it. And then somewhere over here I can set it to 0 just to make it start working, maybe somewhere around here. And then we have our animation cycled. Yeah, alright. But maybe it moves kind of too much. Maybe, yeah, it kind of attracts too much attention. Okay, let's create a new animation layer. And then set it to 0. And set key. So 0 is effectively 0 position, no motion. Now I'm going to set it to the same value on all the frames. As a result, we have kind of reverse curve for our animation on the separate layer. You see that the character moves right now and nothing is jiggling. Because there is no physics, so because it is being countered. And now I can control the weight of this layer and effectively control the degree of this jiggliness. So if we have our weight set to 1 and we have no physics, if I start to decrease it, we're gonna gradually get the physics back. And we can decide what result satisfies us. And let's say it is ready. Of course, I can leave these animation layers as is, or I can break those down if needed. Or if I maybe want to delete the physics itself, gonna select those joints, gonna bake those, and then I can delete unnecessary groups and planes, because the animation has been baked to my joints, my original joints for this animation. I hope it is clear. Alright, let's continue and let's move on to a bit more difficult example, to the chest. Of course, we want to create a physical motion, so I'm going to do the same. I'm going to create the necessary buffer frames for warming up of our animation. So maybe I want to create something like this wobbly jiggly motion. Also, I can see that hair are also skinned to these joints. Oh, okay, it's not a problem. It's alright for now. But you have to remember that when we're animating the female chest, the motion itself is actually divided into two parts. The first one is essentially translation, like moving up and down. Something like this. And the second one is rotation. Those are kind of two different things, different settings. So what we can do? At first, I'm going to apply the point, so we can apply our physics. And now we have our physics affecting both translations and rotations by default, but it is advisable to separate those channels, so to essentially apply physics separately to translations and separately to rotations. So right now we have those two joints. Right here I'm going to select the rotations and break connection. Right mouse button, break connection. As a result, we're going to get the physics simulation only on translations. What else you can do? We also have our translate Y animated, and it is kind of motion, kind of inside our body and outside our body. I'd say that it isn't necessary, so we can break connection here as well. And now we have our physics applied only to necessary channels, so up and down and left and right, which makes sense. I'd say it's going to be more convenient for animation. Alright. After that, let's actually lock those channels just temporarily. And now I want to get rotation separately for physics, I mean. Let's use aim locators. Let's move it over here. This one over here. And maybe the side locators maybe somewhere around here. Now I can control my chest separately with those separate locators. And then we can apply the physics. And of course, let's actually set something, change some settings. Yeah, over here. Let's increase the damping effect, because I think right now the chest is too jiggly. Yeah, maybe, yeah, something like this. I think it should work nicely. And maybe this result satisfies me, maybe it's fine for my purposes. I can select those joints. I'm going to unlock the translates and bake. And now we can delete everything that is unnecessary. You see it no longer affects our rig. I'm going to delete it. Now we need to cycle the animation. Let's go back to the 0 frame. Then I'm going to create a new animation layer. Then I'm going to apply this button, this function. As you can see, again, we previously had this difference, and now we are cycling this animation. It works fine. And again, I'm going to create a new animation layer in order to create a contour animation, in order to control the degree of this animation, the effectiveness or weight rather of this animation. Just set it to 0 as usual, then you can change the weight and get the satisfying result that I like. Very nice. Yeah, I think we can leave it as is. And of course, after that you can break down those animation layers or work with these curves as you need. Maybe you can delete it and start from scratch. It's up to you. Alright, good luck.